Periodic trends. How are periodic trends related to intermolecular forces? Well, let's use freezing point as an example. If we look at freezing point, it increases as we go down a group. So we want to explain why that would be, and it has to do with our intermolecular forces. We've got two factors that we need to think about. Our first is as we go down a group, the atomic mass increases. That means the average velocity of the atoms at the same temperature will decrease, they'll slow down. Which means that those atoms are going to be in a more locked, solid pattern. Also, as the atomic number increases, the number of electrons also increases. And what that's going to do is it's going to increase the probability that the electrons are going to be unevenly distributed at a particular instant in time, which means we're going to be increasing our intermolecular forces between the particles. So, we say that larger atoms are more polarizable than smaller atoms. The more electrons we have, the more likely it is that we will form those instantaneous dipoles. Now let's look at some characteristics of liquids. Okay, one of the things we know is that liquids have low compressibility relative to gases, and that's because the particles are closer together and there's less of an ability for us to push them even closer together. Liquids lack rigidity, which we would see in solids. Liquids have high densities, at least compared to gases. They tend to form beads as droplets. They have a characteristic called surface tension. And we can describe liquids with respect to their viscosity, or their thickness. And all of these qualities of liquids can be related back to intermolecular forces. Since we've got higher intermolecular forces in solids than in liquids, and higher intermolecular forces in liquids than in gases, it can explain a lot of these characteristics of liquids. So let's look at a diagram here. Over on the left, we've got gases. We know that gases fill up the container that they are placed in. There's very little, if no, intermolecular forces holding those particles together. If we look at liquids, liquids take the shape of the container that you put them in, but they don't have a definite shape. And the reason for that is they've got a greater intermolecular force than gases, but they've got less intermolecular forces than solids. Solids have a definite volume and a definite shape because they have the greatest intermolecular forces out of all three states. So when we want to summarize up intermolecular forces, when we look at ionic bonds, they're formed between ionically bonded molecules, and those are the highest of our intermolecular forces. Then we've got hydrogen bonding, which forms between molecules that have a dipole attraction. We've got dipole-dipole intermolecular forces. And then we've got London dispersion forces. The strongest are ionic, the weakest are London dispersion forces.